So let's suppose we have this function here, and what we're going to do is revolve this around the x-axis, okay? So if I did that, it will kind of mirror itself, and I'll end up with this shape right here, if I'm looking at just it from the side. Now, if I add this third dimension, what I'm going to end up with here is kind of this three-dimensional shape here that looks like a bowl that's open sideways, okay? So in this case, because I'm rotating around this angle right here, I would use a function of x. And if I basically find the area of just one of these circles here, and then I just say, well, there's an infinite number of these circles as I go all the way through, I'll be able to actually find the volume of this thing. So the area of a circle would be pi r squared, and I'm just going to integrate that from whatever bounds I want, and then because I'm revolving around the x-axis, a dx here. Now it's really important that we note that the radius in this case needs to be a function of x, okay? So what we typically do is we rewrite this. We'll move the pi outside because it's a constant. We have ab, and then I'll have some sort of radius with respect to x, and that is squared dx. Now if I take this exact same scenario, but I rotate around this axis instead, so this way it's now going to go like this. So I'll have this weird kind of V-like shape, and the circles that I'll have here, the shape it makes is more like a cone that opens up like this, but I still have the same circly shapes, but this time the radius goes in the y direction. So when I do the same exact scenario over here where I do the AB and find the area of one of these circles, it's dy because I'm going in the y direction, opening up and down for my a's and b's here. So when we simplify this one out, we normally would write r of y squared dy. So you just have to pay attention to which axis you're rotating around, and that tells you what type of equation to put in here. If we're rotating about the x-axis, then we're putting something that has the x variable in it. If we're rotating around the y-axis, we'll be putting something that has the y variable in it. And we'll be using the y mins and maxes here versus the x mins and maxes. Let's do some examples of these so you actually understand what I'm talking about. So for example 1, we're being asked to find the volume of the solid formed by rotating the region bounded by the x-axis, y equals the square root of x, and x equals 1 around the y-axis. So the first thing we want to do is just find that region that we're going to rotate. So I'm going to start off by graphing the square root of x. I have x equals 1, so I'm just going to, ooh, that was a great noise, wasn't it? Put that line there, and then we have the x-axis right here. So here's the region that I'm now going to rotate. So when I rotate this region, it's going to come down here, and then I'm going to have these lovely circle cross sections when I rotate it. My radius is going to be defined by the equation y equals the square root of x, and I'm going from 0 to 1. So I'm going to have pi, because I'm doing the volume, and the area of the circle is going in here from 0 to 1. So I have pi r squared, but r is the square root of x, dx. Okay, so what I really did there was pi r squared, but I'm saying that r is equal to the square root of x for this circle. So once I simplify this out, okay, that's going to end up being pi integral of 0 to 1 of just x dx. So I'll have 1/2 x squared from 0 to 1, and I'm multiplying all of that by pi. And I'll just get pi over 2 units squared. So not units squared, sorry, units cubed, because we're doing volume now, okay? So that's the neat thing, is we're going the next step further, which is we're accumulating areas using the integral. Number 2, we're finding the volume of the solid formed by the region bounded by y equals x to the third, y equals 8, and x equals 0, and we're rotating this around the y-axis this time. Okay, so let's just sketch a quick graph of this. Here's my x to the third graph. I have y equals 8 is up here, and x equals 0 is right here. So this is the part of the graph that I'm rotating, so I'm just going to ignore the rest of it. And then I'm rotating it around the y-axis, okay? So when I do that, I'm going to end up with a shape kind of like this, and then I have circles going this way. So my radius is going to be going side to side, which means I need to be using y here. Okay, so since I'm rotating about the y-axis, I need y's in my equation. So I'm going to rewrite this one so that it's the cube root of y. And I'm going to integrate from 0 in the y direction. We're going up to the y value of 8. Okay, I have my pi r squared, so that's going to be the cube root of y squared dy. So remember, this is just pi r squared, where my radius is defined by that equation right there. So if you have your calculator, use your calculator. If not, do it the old school way. I'm going to just cheat and jump to the answer. It's units cubed. Don't mess that up. Not like it really matters if you mess it up right now because you've already taken the AP exam and this wasn't on the AP exam anyway, but units are super important for them and they would take off point at least of the 9 points in an open-ended if you didn't have proper units. Let's take a look at this equation. If I were to rotate this about the x-axis, I would end up with a kind of a weird looking shape here that's going to be tricky for me to draw, but I would end up with like a solid base here, and then I would have this kind of hollow area here where there was just nothing that was going on in between. So think about like an actual bowl. How like if we have a bowl, it has a certain thickness to it, but then there's nothing in between it. So its volume is going to only be this part right here. What we were calculating last time, okay, was if this entire thing was filled in. So what we're saying is, well, what if it's not entirely filled in? How do we go about doing this? So it's similar. What we actually end up having is something called a washer. So if I look at what this would look like, if I just took like a cross section right here and looked at this graph, I would end up with something like this, okay, where there was nothing in the middle and then I had stuff on the sides here and here, okay? And I would have a little radius right here and then I would have a big radius right here. So if I want to find the area of this donut shape, okay, or the washer, I'm going to do pi big R squared minus pi little r squared, and that would give me the area of this. Now if I want to find the volume, I'm just going to integrate from a to b and then do either dx or dy depending on which way we're going. So this one is set up using x equations. If it was the other way around, so I was rotating around the y-axis, I'd be using dy. So what we're going to do for this washer one is basically identify the big radius and the small radius and then just plug this into the equation, which we do typically factor the pi out and write it out here instead. So we end up with big R squared minus little r squared dx or dy, and then we multiply that by pi when we're done. Okay, for 3, we're getting the area between cosine x and sine x, rotating it around the x-axis. Okay, so I'm just going to sketch a quick little graph of this. Here is going to be cosine x. I'm only going to graph a little bit of it. Here's going to be sine x. And I need to know where they intersect. That happens at pi over 4, so I just set them equal to each other and solved. And then 0, and we're rotating it this way. So I'm just going to remove this extra stuff here so that I'm not getting confused by it. And what I need to do is go from the axis I'm rotating from, so right here, go up and up. And now I can very clearly see which one is big R and which one's little r. So big R is going to be the cosine equation, little r is going to be the sine equation. I already know my bounds are from 0 to pi over 4, so I'm going to do volume equals pi 0 pi over 4 of big R squared, so cosine squared x, minus little r squared dx. I'm just going to definitely use my calculator for this one. These would be really difficult, I think, to solve without one. We'd actually have to use an identity that this is cosine 2x, and I don't think we want to deal with that. So let's just use the calculator and end up getting pi over 2 units cubed, okay? So when I did this in the calculator, I actually ignored the pi and just did it with everything else in radian mode, and I got 1/2, so I just multiplied it by the pi at the end. And that's the way I can get an exact answer while still using the calculator. 4 wants us to first rotate it around the x-axis and write that set of equations, and then rotate it around the y-axis to see what happens with that. So let's just draw it first so that we get a nice visual here. So I have y equals x, y equals 0 is right here, and x equals 2. Okay, so this is going to be the area that I'm going to be rotating around, this little region right here. So if I'm doing this about the x-axis, okay, so that's going this way, then this is actually really straightforward. This is just the area underneath the curve, really. It's just going to be right here. I only have a single radius because the other equation would be 0. So when I set this one up, it's going to be from 0 to 2 pi r squared, which is just going to be x squared dx. And then I can just evaluate this, and I will get 8 pi over 3 units cubed. So that's rotating it this way. So I would end up with kind of like a cone that goes sideways like that. Now if I rotate it the other way, okay, so that's rotating it this way, I'll end up with a voided kind of shape here, okay, where I have nothing in between, and then these parts right here are the three-dimensional parts. Okay, so kind of like bunny ears or something like that. So when I set this one up, I'm going to go from the axis I'm rotating around, so the y-axis, and I can see that I have a big R and a little r because I have two different equations that I'm going to hit. So I'm going to have x equals 2 as the big R, so I'll have pi, and then 2 squared minus little r is going to be my y equals x, but I'm using y, so I'm going to have y squared and then dy. Again, if you have a calculator, use it. If you don't, then do it the old school way. I got 16 pi over 3 units cubed. So it actually had more volume by rotating it this way than it did by rotating it that way.